Thanks to everyone for coming out. I don't know if you had a chance to go around the gallery, but the reason we invited our amazing guests, and I'm just so thrilled to have them both here, was out of inspiration given the themes of the exhibit, the Hiroshima panels, in the next gallery, and also there's 3 or 4 dimensions of this show that are relevant to our topic tonight. And so we thought we would try to do one of these scientific controversies on the issues raised by nuclear power, nuclear energy, nuclear waste. And really, we could not have better guests, and so much so that we're stealing Peter's image from his film, which I'll show some more clips from his film, and we stole his title. I hope he doesn't mind. Do you mind? Actually, before we get started, I just wanted to ask, what got you into a film about this particular issue? I mean, I know your other work, you've thought about relativity and space-time and physics, and what brought you to that particular topic?
Well, my work for the last period of time has been gone back and forth between film and writing, and I'm particularly interested in using film as a way of adding a certain dimension to the kinds of work that I do in more literary or scholarly form. And the first film I did was called Ultimate Weapon, about the struggle in the physics community that really ripped it in two, about whether they should build the hydrogen bomb or not in the period 1942 to 1952. Mm-hmm. And then a second was it's called Secrecy, which I made with Rob Moss, with whom I also made the film Containment. And it's about national security, secrecy, and democracy. And you might say, how do you make a film about secrecy where there's nothing to show and nothing you can say? But that's another story. And then with this film, I'd been writing about these territories that are a kind of very strange admixture of the most biodiverse and the most contaminated with nuclear materials. And so I wanted to think about what it meant to try to hold these materials in place for a period comparable to that of human civilization. And that seemed to me a really difficult question that has a scientific part, but also a part that involves the rest of us, the rest of society.
It's really a very moving film in a lot of ways. I really hope everyone gets a chance to see it. And Alison, you were once the chair of the Nuclear Regulatory Commission, every girl's dream. Why did you take this very difficult job? And then also, why did you give up this very difficult job?
Good questions, I suppose. I took the job in part because I didn't know really what it was. And if I'd known, maybe I wouldn't have done it, I don't know. But it's kind of hard to say no when you're told the president would like you to do X.
If it's tap dancing, you'd be doing it. So could you just tell people quickly what the role of the NRC is?
The Nuclear Regulatory Commission regulates nuclear materials and nuclear facilities in the United States. Not only do they regulate the operation of nuclear power plants, but also research reactors, nuclear materials transportation, nuclear waste facilities, and nuclear materials used in the United States. There are over 20,000 nuclear materials licensees in the United States. Many of you have probably intersected at some point in time with nuclear materials when you get some kind of treatment at a hospital or doctor's office. So all of those are regulated by the Nuclear Regulatory Commission. So what's the next question?
I think we're going to get back to the next question, which is what you did while you were there, and I think we'll talk about that in a second. Since this is scientific controversies, I do want to do a little bit of the science leading up to just the entire idea that we could ever release energy from the nucleus. So if you guys are willing to indulge me, I'm going to do like 30 seconds on E equals MC squared. So that I can do E equals MC squared in 30 seconds, I swear to God. I've gotten this down. Oh, there's Alice and Bob. Okay, if you can see. So you see how Alice thinks she's standing still and Bob moves past her, right? So this is the argument. If Alice sees Bob move past her and Bob were to hit her, she would think he had some energy of motion as he hit her. Okay, let's see it from Bob's perspective. I don't know why there's 2 Alices there. Oh, we're having a weird glitch. That's okay. So from Bob's perspective, Alice is the one who's moving. Bob thinks he's standing still completely. They're floating in outer space, they have no markers. He sees Alice come by. If they hit each other, he thinks it's Alice's energy that's being imparted to him because he's not moving, right? So let's do the next slide. Einstein started to think, well, according to Bob, he's just moving in time. He's not moving in space. And Alice is moving in space. So Alice's motion in space is where the energy is coming from. If we could see that one more time. But Alice says, oh, perfect. Alice says, oh, but I'm just moving in time. You're moving in space. They could have this argument forever. They could never resolve this argument. So Einstein has this next thought. He says, actually, the only way to make this consistent is if both of them have energy. Both of them perceive that there's some energy, the person who flows only through time and the person who flows through space. And so he deduced, and I'm not going to explain this part, but he deduced that the energy of your motion through time was E equals mc squared, his most famous equation, the world's most famous equation, that the energy of your flowing through time was associated with your rest mass, with the mass that you have, times the speed of light squared. And it's such a beautiful observation. It's so strange, right? The idea that you move through time and through space, and then with it comes energy. There's no way Einstein thought there was any implications for weapons, did he? This is 1905. He can't get a job. You know, he's an unemployed physicist working in a patent office, and he has the physics department in the bottom drawer of his desk, right? And you know, he said about himself, when I was a student, I was no Einstein. And he comes up with this remarkable realization. How long is it before people start to think that this is something that energy that could be harnessed? It's a while.
People begin to speculate, and even Einstein thought there might be experimental ways of seeing that energy in the decay of radioactive atoms.
Yeah, so they knew about radioactivity.
So they knew about radioactivity, and then, but what happened was in the 1930s, just before the opening of World War II, nuclear fission was discovered, that you could take an atom and break it.
There it is.
Exactly.
Nuclear fission.
And then immediately, scientists in both sides of the belligerent actions that followed realized, Heisenberg, of the famous principle, went to the Bureau of Armaments in Nazi Germany and said, you know, look, this might become a weapon. And Szilard and Teller and came to Einstein and they said, you better warn the president because this could be serious.
It's interesting. So 1938, the uranium atom in particular, which is really what's still used in nuclear plants, it's realized splits into two whose E equals mc squared energy is less than the original atom. And so something, or element, so what comes out is a tremendous amount of energy. So it's really rooted in E equals mc squared, which I'm not sure everyone appreciates. But once they saw this fission, they realized that you could go towards weapons because it could have a chain reaction where one of the splitting of the atom induces the splitting of more and more and more. Lise Meitner, who was one of the scientists involved in this in 1938 specifically with uranium, said, you know, I will have nothing to do with the bomb. But in some sense she did, right, inadvertently. And I think part of what I'd like to talk about eventually is like containment of ideas. Like how do you have this innocent thought in 1905 about E equals mc squared? And this innocent discovery, to some extent, in 1938, and have to accept that you were on a chain that led to the bomb. In 1941, I don't know if this is actually true, do you know the play Copenhagen? The character, I don't know if the real person said this, but Bohr in Copenhagen says to his wife, I don't think anyone's thought of a way to use quantum mechanics to kill people. You know? But it's 1941, and it's not much longer before someone thought of a way to use quantum mechanics to kill people. Can we see this next slide? This is, of course, the consequence of E equals mc squared. This is actually the Nagasaki plume. So it's the second and last bomb used to date in nuclear warfare. It was dropped, obviously, on Nagasaki. It was August 9th, 1945, I think so. August 6th was the Hiroshima bomb. I don't think we need to discuss the pros and cons of nuclear weaponry. I have a feeling there's really no one here who thinks that nuclear proliferation would be a good thing. But if we could just see the next slide. we get on to the Cold War. Now this is, if we could start this, so this is from Containment. Peter, do you want to tell us about this, what this is?
So,
This is from Peter's film.
there are two ways to make an atomic bomb. One is to use uranium, which is difficult. That's what the Iranians are doing with their centrifuges. Like when you separate blood, you separate two kinds of uranium. But chemists can't help you because it's the same element. It's just uranium. But there's one kind that's a little bit lighter and can be used to make nuclear weapons, and another kind that can't. Then there's a way that you can take, if the uranium rods are put into a reactor, they can turn into, small amounts of plutonium, another element that's even heavier than uranium, can be produced. And you drop these into hydrochloric acid and some other things, and you get out the plutonium. And that's how countries that want to mass produce nuclear weapons want to do it, because the chemists can get the plutonium out. And so they cut up the pieces of the rods, and they get dumped into these big canyons of acid. It's dangerous, it's dirty work, and the stuff that comes out of it, the acidic sludge that comes out of it after you've removed as much of the plutonium as you can, is highly radioactive, and it's stored in 250 or so tanks, each about 1 million gallons at Hanford, Washington, and in the Savannah River site in South Carolina. And one of the problems, one of the biggest problems of containment is, how do you hold this stuff from getting out? And some of it already has gotten out into the Columbia River, but there's a process that trying to mix this stuff now with sand and not make it into glass bricks, glass cylinders, glass logs. And that's, they were originally supposed to go to this place called Yucca Mountain. Alison's done lots of work on this, and Yucca Mountain was never opened, but right now these glass rods are sort of stuck, all dressed up, and no place to go. And that's one of all of these problems are trying to stop this stuff from getting out, and it's very tough.
And those were weapons plants.
Those are weapons plants.
Both Hanford was a plutonium separation facility for the bomb, the Hiroshima bomb, right? That was plutonium, wasn't it?
Hiroshima was uranium.
Was uranium. Okay, so Little Boy was the plutonium bomb. And the Savannah River site was really Cold War inspired.
Yes.
So how many warheads do you know, Alison, the kinds of vague numbers of what kind of production of weapons was coming out of the Savannah plant?
Both Savannah River and Hanford both produce plutonium for nuclear weapons.
And now it's the Savannah site is still active, but
not producing
not as a weapons site.
Yeah. They're a cleanup lab.
They're a cleanup lab. But it's does the NRC look at labs like this because it's not commercial?
Yes.
Okay.
That's with caveats. Little footnote.
But it's leaking, or has leaked.
Yeah, not the NRC's purview. Completely. There are parts of it that the NRC has been asked by the federal government to oversee, but it's a difficult relationship because they don't have the same kind of powers that they have over civilian facilities.
So let's just look at this next, which is, that's nuclear energy. We'll talk.
Or coal.
Or coal. Is this
gas.
a coal?
You can get cooling towers are for everybody.
Can you talk us through that?
It's just boiling water. You have to boil water somehow.
And so the boiling water just...
And when you make electricity, you boil water, or you use water to cool the facility, and sometimes if you don't have some other natural large source of water to dump into to cool your water and to be a source of cooling water, you use cooling towers.
So this could be, I think this is in particular a nuclear plant, but you're just saying what you do is you heat water, it runs turbines make electricity. Figure out how you want to heat the water. It could be coal, it could be oil, it could be nuclear energy.
It could be solar.
Okay, it could be
solar.
geothermal. It could be geothermal.
Natural gas.
So can you just I know you're an expert in the fuel cycle and have concerns about this, but in particular with relationship to waste, just can you very quickly talk us through how that works? We start with uranium rods, as Peter mentioned, and it heats the water, and then what happens? How does it heat the water, and what happens? Just briefly.
So depending on the design of the reactor, most of the power reactors in the United States and in the world are what they're called light water reactors, and so they use just regular old water, like tap water, a little cleaned up, to both cool the rods and moderate the nuclear reaction. And so you put your fuel rods, which are uranium dioxide pellets, stacked together in these long cylindrical tubes about the diameter of a quarter and 12 feet in length, and you bundle them together. And those are put into the reactor. You run the reaction for a while. After a while, enough other products build up so that the rods really can't be used anymore. You take them out of the reactor. You have to put them into basically a swimming pool, a very deep 40-foot swimming pool, to cool them and to keep the radiation levels down. And then you have to decide what to do with this material. And right now, nobody anywhere in the world has come up with a final solution. But everybody agrees that the best solution is some kind of deep geologic storage.
So how much of this fissible material is actually used for energy in the light water reactors?
So
what percentage, roughly?
There's a fair amount of uranium, especially the fissile piece that you were talking about, left over. But it's difficult to reuse it.
It gets kind of just...
It's difficult to reuse the uranium because it gets contaminated with other isotopes, uranium-236 in particular. You do produce plutonium.
The plutonium.
You can reuse the plutonium once, and some countries do, France in particular.
So it was my understanding, maybe this isn't right, but you could say something like very impressive about nuclear energy, like 1 kilogram of this uranium in a light water facility is equal to what, 1 million kilograms of, would it be coal? Okay, so that's pretty good.
Yeah,
That's
it's highly
good.
concentrated energy source.
Right, but that only a few percent of
And
it
it
is
doesn't
actually
produce
used.
carbon dioxide.
Right, so, okay, people say that's green because it doesn't pollute the atmosphere, but this 96% radioactive material that you're left over, 96% of it that's left over is really bad stuff, which is not very green.
Some of it's really bad stuff.
Yeah. And so how long does it have to cool in these pools before you can start to worry about what to do with this waste?
In the United States, you have to cool it at least 5 years before you can take it out of the pool and put it into what we call dry cask storage. And these are just, I have an image somewhere, but these are just basically really big concrete casks, 6 feet in diameter, 14 feet high, that are steel reinforced. And that you just put the spent fuel rods in there and they can be passively cooled there.
So can we
But
see
still,
this?
that's not a final solution.
Can we see this next? So basically, oh, this was one suggestion, which I also took from Peter's film, if we could run this. And actually, Galison, in the film, you're speaking very eloquently about this. One of the suggestions for what to do with this waste involved the sun.
Right. Yeah. Before everybody sort of settled on deep geologic repositories, other suggestions were shoot it into outer space, but those of you who are old enough to have experienced the Challenger disaster know that that's probably not a good idea.
Like this ill-fated rocket doesn't quite make it out.
I mean, even when we have our best and favorite school teacher in a rocket, and we put all the money that we can find into protecting her, it blew up. And if it's a garbage barge, essentially, into outer space, it's not going to be that well protected. Now, I mean, I should say something also about Galison. She did something very admirable, or has tried over many years, to tell people that you really shouldn't be packing and keeping so much of our waste in these big swimming pools. Because the problem is that it's cheap to just take them out of the reactor and put them in these pools. And even the old, cold stuff, in the United States about 80%, in the world about 90% of the waste from reactors, the rods, are in these pools. The problem, it's all great if the water's flowing through and it's nice and clean and everything works well, but if If it stops, the rods that are just recently out of the reactor are incredibly hot. That's what they're designed to do, to boil water. So at Fukushima, when they lost the ability to cool these rods because of the earthquake, which knocked over some of the external power, and the tsunami, which destroyed their backup power, and the roads were blocked, and there was a lot of things that went wrong, the pool started to boil. And luckily enough, they had blown the roof off of these places because the hydrogen had accumulated, and they were able to get more water in. But it was worrisome enough so that the Prime Minister of Japan was concerned that they might catch fire, and if the wind was blowing towards Tokyo, he'd be faced with a task that had never been successfully executed anywhere in the world, of evacuating the 50 million people in Greater Tokyo. And he said, and in the film, he says that he thought they might lose modern Japan.
Yeah.
Now that's a real worry. And what Alison's done, and I really think it's great, is to try to convince people, both before and during her time in office, that you should get the old cold rods out of the pools to minimize what could happen if there was a pool fire. But that's really tough, and it's not going much of anywhere right now.
I have some great footage of Fukushima coming up, but this idea of the rods, I understand that there are many, many pools because, well, if we could just show this one, this is just for fun in the background. I think this is the Savannah river site just dumping stuff into a hole. Will it run? So a lot of the waste is really just on the sites. It's not in these deep geological facilities, which we're going to get to. This is a very sophisticated disposal system. Makes you feel good, right? And then they're going to cover it with dirt. So this is a little nerve-wracking, but the pools, in some sense that you're both talking about, are even more dangerous, right? Because they're up in the air, right?
In some plant designs.
Like Fukushima.
Sorry?
Like Fukushima.
Yeah. So they're up in the air. They're not necessarily terribly well contained. The walls aren't that.
It's not that they're hanging in the air, by the way. They're on like the fourth story of the building.
And do you feel so? Is that still considered a safe practice? I mean,
by some people.
Practice.
Not by
Clearly by some people.
Now, when the NRC has to the NRC has to do licensing for a lot of these plants. So these plants are often, they're old technology. We are not using very sophisticated nuclear energy technology. It's old. It's from the 60s, really.
Or 50s.
And the licenses get renewed, but they get renewed for 20-year spans. So that kind of practice of having these cooling rods, okay, not dangling up in the air, but nonetheless a few stories up and maybe not the most secure building. We're talking earthquakes, terrorist possibilities, in the case of Fukushima, which we'll come back to, tsunamis. They would get relicensing approval despite that. That's not considered a...
It's not looked at.
Okay, but you don't want to see that happen. So
I want to see what happens.
You don't want to see that continue, that practice.
I want to actually understand it better, and I didn't even get that far, so.
So tell me about the Yucca Mountain program.
So in
as an alternative to this
the
practice.
Late 70s, it became clear that there wasn't going to be a good plan for dealing with the spent fuel. So Congress took it upon themselves to pass legislation, to pass a law that said, okay, we've got a plan for dealing with nuclear waste. The Department of Energy is going to find a place to put it, and they're going to manage it. There's going to be a couple sites in the country. We've got a plan going forward. And it became, of course, political in the 80s, and Congress ended up amending the legislation and saying, we're only going to look at one site. That's going to be Yucca Mountain in Nevada, on Nevada test site land. And Nevada said, no, we don't want that. They called the bill, the law, the Screw Nevada law, literally, and they've opposed it ever since. And the Department of Energy went forward. Eventually, way past when they were supposed to, which was 1998, they actually submitted a license application to the Nuclear Regulatory Commission, and President George W. Bush blessed it. The state of Nevada vetoed it. Congress overrode the veto. And it was moving forward until President Obama came in and said, okay, we're going to stop this. And so they halted it, they dismantled the program within the Department of Energy, but we're now at basically a standstill because many Republican congressmen and some Democrats in the House of Representatives really want Yucca Mountain to go forward.
Now, you were sort of opposed to Yucca Mountain, I thought, for geological reasons.
For technical reasons.
And so what was your concern geologically?
There have a couple of concerns. One is that the area around Yucca Mountain is both seismically and volcanically active. That means that there are earthquakes there on a regular basis, and there's potential for volcanoes.
Blasting tanks of radioactive material into the sky just sounds like that would be a concern.
But actually, the bigger problem is that the idea is to put the repository above the water table. You might think, well, that's a good idea, but actually not for uranium dioxide. It's much more stable when it's not exposed to oxygen, and that usually means below the water table. So most countries that are developing repositories, and now Finland and Sweden and France are much further ahead than the United States, they're all looking at sites that are below the water table.
And so was there some concern that these these casks would heat up and that they could possibly break through some of the rock above?
No.
That was, okay, so misinformation that I'm perpetuating.
What Alison said is really important. If it's above the water table,
Yeah.
it can oxidize. It can rust,
Rust.
essentially.
Yeah.
And so you have to use this incredibly expensive, difficult to make titanium alloy to both make the casks and to make shields for it. And they have to last for very long periods of time, tens, even hundreds of thousands of years. So that it's a tremendous engineering problem that you've gotten yourself into by putting it above the water.
Now, how long does it have to last? Because it's the uranium's not so bad, right? It's the plutonium that's bad? Or
There's lots of things that are bad.
But what's the one with the longest half-life?
It has to last as long as society wants it to last.
So
It's an arbitrary number.
right, so 5 years in our foresighted society until the next administration. So for plutonium, the half-life is what?
24,100 years, depending on the isotope, of course.
So about half the plutonium will deplete, leaving the other half. And so how long before it's kind of gone?
Takes about 10 half-lives for something to be considered gone.
So
So for plutonium-239, which is makes up the majority of the plutonium, over 240,000 years.
Right, so 240,000 years you want to have this stuff, if you care about that far in advance, you want to have the stuff buried and buried well. Can we see this next about WIPP? So WIPP, which is the Waste Isolation Pilot Plant, is it the only deep geological?
The only licensed operating.
Well, sort of operating.
Can somebody tell me about this? You guys can jump in.
So in order to get it passed and approved to get going, there are a couple of things that had to happen. One of them was they had to agree that they just use what's called low-level waste. Now, these designations are really tricky because you can have low-level waste that's more radioactive than high-level waste because of our strange classification system. High-level waste sort of mostly means that it comes out of a reactor. And low-level waste can be things like test tubes and smocks and all the sorts of junk that's there. But that's not exact what I'm saying because it's really a deep regulatory problem. And every country does it differently. It's a total mess, the classification. But it was authorized not to take the reactor waste, but just this other stuff. And that was waste that was contaminated by plutonium or things like it.
And just weapons waste?
Weapons waste.
Yeah, so not commercial waste.
Not commercial
So the
waste.
commercial
the
plants
deal.
still have their stuff.
So they started to bury this stuff. It was held up for years. There were protests, and
Where is it
protesters.
again?
It's in southeastern New Mexico, about
Carlsbad.
25 miles from Carlsbad, where the famous caverns are. And so it was it was held up for over 10 years, and protesters, they didn't want it going through their towns. They had to build bypass roads around northern towns and cities in northern New Mexico. It was a big argument. The place, at first only about 30% of the people near Carlsbad wanted it. Finally, they got it started. And then what Alison alluded to a moment ago when she said sort of operating is there was just an accident there on Valentine's Day, 2014. And the Los Alamos, who was just packing some of the waste that was going there, there was a discussion, and they said, you got to use inorganic kitty litter, which is clay-based, the kind you buy in the store, which keeps the moisture. You don't want to bury moist stuff in salt. That's not a good idea. So the person wrote down an organic kitty litter. They bought this Sweet Scoop, which you can get at the store. Sweet Scoop, it's a...
oh, my confidence grows.
And so they used the wrong kind of kitty litter, and because the organic materials combined with the radioactive salts to make a patented explosive, which ignited underground and caused a fire and contaminated. It'll cost about $500 million at least to get it reopened. It's closed now. And 22 workers were exposed to plutonium, not very much, very trace quantities, but it really was the kind of nightmare of people. So I think Alison thinks, and I do too, that underground is where you want this stuff to be, but that doesn't mean that it's guaranteed to never leak. It just means you're trying to contain stuff that's very hard to contain. Mm-hmm. And that's tough, but it's probably where stuff should go.
Just as a footnote on Peter's great explanation, the Department of Energy manages the Waste Isolation Pilot Project facility, and they regulate themselves.
Well,
I mean, the origin of Alison's agency, so to speak, Alison's former agency, the Nuclear Regulatory Commission, was created in part to separate the Atomic Energy Commission into a regulating part and a part that's for the advancement. We do this more and more in different sectors. We do it with flight. We now have the National Transportation Board that looks at accidents, and then we have a part of it that's trying to advance, Federal Aviation Authority, that's trying to advance aviation. Many things have separated, but the bizarre thing that Alison is describing here is that the weapons project didn't have that separation. They're self-regulating. And the reason it's been separated in so many countries is exactly this problem. You can't be both in charge of advancing something and regulating it at the same time, or you can be, and it doesn't often work.
So can you just tell me a little bit, just because I think it's fascinating scientifically, why it's there? It's not just because it's a remote part of the country where they could pass it through the community. There's a specific reason why that site was chosen.
Well, really?
Well,
it's not all scientific.
Tell me about salt. I'm asking about the salts. Tell me about the salts.
It's the rock that the repository is in is salt. It's like what you put on your food every night, or morning or afternoon. It's rock salt, and rock salt has a couple of qualities. And one quality is that it provides an anoxic environment, no free oxygen, over time, because salt actually moves plastically. So when they drill a hole and drill a tunnel there to put the waste in there, eventually the ceiling and the floor are going to meet and sort of package the waste nice and tightly. It's kind of cool stuff.
Yeah, and the salt's also been there for, 250 million years? So something's protecting the salt in the first place, which also must make it look like an attractive site.
Yeah. So there's no water there, so.
Right. So, this is a lot of waste, though. What are we talking about? We're talking about the WIPP plant wanting to take waste until, what year? 2017, something like that?
No, it's about half full, not by what could go there, but what's authorized to go there. Mm-hmm. You're always dealing with an environment that's partly physics, partly politics, partly economics, and partly regulatory. And the regulation that was agreed to was that they'd have, 6 million cubic meters of waste, something like that. And they're about half full to what they're authorized to go.
Tons.
Oh, yeah.
Tens and tens of tons.
So
of
if it were to end, then at that point you have a new problem, which is once the guards go away, and the guard dogs are gone, how do you keep
Beautiful.
it safe?
Let's look at this next. This is beautiful. This is really part of Peter's film. I'm sorry, I'm going to preempt you because this is in your film, and this is really moving. You talk about how do we tell people things, and you make this beautiful comparison with talking about communicating to people in space, extraterrestrials. This is the phonograph, the gold record that went on the Voyager mission, and the problem when they sent this out to talk to aliens, right, was the idea, we're going to put this on the Voyager mission, launched in the 70s, we're going to show them the best of ourselves, right? And how do you do that? You can't use English. That would obviously be very foolish. You can't use language at all. And so a decision was to use music and lots of pictures, which even that I think is kind of funny. How do we know aliens have eyes? Right? What if they just sensory are not geared towards electromagnetic collection? But these are the images that were on Voyager, and they're really quite sweet, aren't they? They're sort of average snapshots. I just love it. But it is kind of a narrative about who we are and how far we've come, and an astronaut here making it to space, and then eventually Voyager itself floating out. We're lovers of music and food, right? We're animals that make babies. And there goes Voyager. Voyager just exceeded the magnetic influence of the sun. It's really just basically left our solar system after all these years. It's officially kind of interstellar. It'll be 10,000 years before it finds another star system. But in the case of the nuclear waste, we're not talking about the best of ourselves, right?
No, we're talking about the worst. This waste is the waste that's left over from making nuclear weapons. At its peak, the United States and the Soviet Union each deployed about 30,000 nuclear weapons. In 1957, I believe, the combined military forces asked for another 150,000. They didn't get them. We probably built on the order of around 80,000 nuclear warheads over time. This is something that the people at the time of Hiroshima and Nagasaki never imagined. They thought there'd be 10 or 15 or 30. They never thought there'd be 30,000. We now have about 6,000 or so in our active arsenal in the United States, which is still a vast and way too large number. But when they decided they had to warn the future, I mean, there was just environmental regulations to satisfy that Congress essentially had imposed. And how are you going to warn people 10,000 years in the future? Just to fix ideas, 10,000 years ago, Stonehenge was science fiction far in the future. Stonehenge was 4 millennia in the future. So 10,000 years is a really long time. And so they brought in meteorologists, and they brought in geologists and material scientists and semioticians and historical linguists, and what survives over time, and the archaeologists, what do we know about the different archaeological sites? And then they brought in the people that were trying to talk to the aliens, including Carl Sagan and Frank Drake, who was the Drake equation, supposed to give us some idea of how many civilizations there might be in the Milky Way and other galaxies like it. And they said, you were trying to talk since the 70s to aliens. How about the easier task of talking to our descendants 400 generations in the future? So they formed this group, and part of the film is about this struggle to think, do you use language, do you use pictures, do you use equations, do you use, how do you think about this? Or, maybe you need something really different, like somehow have a legend or story. So they really were desperate. They knew this was an impossible task at some level, and yet they felt like they had to make some effort to communicate with
I heard about radioactive cats. Like the idea was that you would genetically modify cats so that when they were near radioactive material, they would change color. And they believed that the relationships between humans and cats would extend into 10,000 years. So they would just be around not knowing they had these radioactive cats, or I don't know, radioactive responsive cats. I don't know how you would call it. But the idea also is fascinating to me because it says something about humanity, like our relentlessness. If we see something, we're going to go and dig. Like the pyramids told us, do not dig here, right? What did King Tut say? Do you remember? I don't know, it's about death.
Yeah,
death is involved, threats of death if you dig here.
And to you, your descendants forever.
Yeah, and what do? We start digging, right? I mean, it's the natural thing that human beings do. So is it impossible to ward us off is sort of an interesting question. Will we see these beautiful structures that are meant to be haunting and deterrence and instead think, oh, I wonder what this is. It's like a treasure.
Yeah, I mean, it was something that they worried a lot about. What kind of materials would you use? I mean, Stonehenge, some of the stones are gone because they're good stones. People use them for building.
They were looted.
The pyramids used to have marble on the outside and gold fixtures at the top. Those were immediately stolen. So they and the reason the current pyramids, what we see now, are still there is because they're kind of rude building materials. They're not very useful, and they're heavy, and they're hard to cart away. But so they thought the designer of this is a very interesting landscape architect named Mike Brill, who died about 15 years ago. And he tried to make things that would convey by their form that there was something not good here and yet not be valuable. So it was a real struggle. It's like, how do you convey importance without value? And that was what he struggled with.
And they also talked about things like an atomic priesthood, which you touched upon, like the idea that there would be generations in this priesthood that would pass on the information. But even that sounds subject to...
I mean, you might say, well, why don't you just not mark it at all and hope,
Right.
the desert's big, or maybe people won't dig there. The problem is if you look at the WIPP site from space, you can see the boundaries of the territory where all the oil rigs have stopped. And so there's no question people will dig there. Maybe oil will stop being valuable at some point, but at least for now, they've negotiated with the authorities to be able to slant drill under one of the corners. So, I mean, they're like itching to get under there.
Right.
So.
And I liked also this idea of spherical marking. You would have to mark inside the earth because who knows, we could send somebody to build a tunnel or automated machines, and they're digging away, and you'd have to be somehow able to mark the interior of the earth. It's pretty fascinating stuff. But in terms of other storage, I mean, you brought up this very interesting thing that Europe and other countries and other continents are doing different things than we are, but some people are doing worse than we are. What about this place in Kazakhstan, the Polygon? Have you heard about this place in Kazakhstan where the former Soviet Union was doing underground weapons tests once it became kind of internationally illegal to continue to detonate on the surface? And they created a mountain that had radioactive material and was being looted. Can you tell me about this place? Do you know much about it?
Sorry, I don't know.
No, I just thought that this was fascinating. They were looting the rocks that had become radioactive from the detonation. And they found people even doing high-level industrial
People
looting.
have done that here.
So tell me.
The Trinity site in southwest New Mexico, where we tested the Nagasaki-type bomb, the plutonium-type bomb, created a lot of glass from the heat of the blast. It fused some of the soil, sand on the surface, and yeah, that green glass. You can go to gem shows and buy it.
That's crazy. And is it very?
Yeah, they call it trinitite.
Is it very radioactive?
Not very. I bought some and then lost it. Who knows where it is?
If somebody stole it, that would be like classic bad karma. They stole like radioactive glass. What about this idea of a free market, that you have a free market instead of government trying to get Yucca Mountain passed and, as you're saying, self-regulating or operating some of the nuclear weapons waste sites? What about a company coming in and saying, I want a free market?
That's how it's done.
Is it with the waste now?
Yeah, that's how it's done in Canada, Finland,
exactly.
Sweden,
right.
All the countries where you're having success.
But not here.
No, because we're not doing it that way.
And and do you think we should be?
It's more complicated here because, as Peter has said, we have a lot of waste from the weapons complex, high-level waste from the weapons complex, those glass logs that you were talking about earlier, as well as high-level waste from the civilian side. And so for a while, the idea was to combine both, to mingle both types of waste in one repository. In fact, President Obama's Department of Energy has recently proposed unmingling this waste, and the Department of Energy would go ahead and just find a place for the high-level waste that is from the nuclear weapons complex and leave the rest out because it's been so contentious.
Can we see this next? This is actually back to Peter. Oh, I'm sorry, I thought we were on that one, but that is beautiful. I do love this. I want to see it anyway. You see, I just feel like I would be invited in to go explore. I mean, it's like art, right? So isn't that the first thing we want to do? If we could see this next, this is the WIPP site with the classic radiation marker over 5,000 years and watching that decay. So the signage here you're talking about is for 10,000 years, but that's really not long enough. I mean,
No.
that's an arbitrary number.
It's somewhat arbitrary. I mean, it was thought to be on the same order of magnitude as the half-life of plutonium, but plutonium also decays into uranium-235, which is an even longer half-life. And but 10,000 years, it was thought that if you could get it to be 10,000 years, which was twice recorded human history,
Right.
then at least that would be the right order of magnitude, and then they'd figure out what to do past that. Now, it should be said that the Yucca site was at one point mandated to have a 1,000,000-year warning system.
Now,
So
before it was 10,000 years,
Right.
and then they revised that out to 1,000,000 years. Actually, they have a dual standard.
these-
But 1,000,000 years, I just want to say, 1,000,000 years ago,
That's a good
we
long
weren't
time.
us. We were Homo ergaster, was our, we're not Homo sapiens sapiens wasn't here 1,000,000 years
Yeah,
ago.
maybe we'll just be radioactive variants of human beings by then, and we'll want to eat the stuff. It'll be like a good resource. Can we see this next? This is back to Peter's point about Fukushima, if we could start this. So just, this is, Fukushima was a nuclear power plant on the coast, right? Then there's this magnitude 8.9 earthquake, tremendous earthquake. A half an hour later is the greatest tsunami, I think you said in the film, since records have been kept. I'm not sure if you said that in the film or if I gleaned that. That's when their problems really began. So along the coast, there were a few nuclear power
That's
plants.
Fukushima there,
There's
getting hit.
Fukushima, right, getting hit by the tsunami.
This is it. Yeah, that's Fukushima.
So first the earthquake hits, they shut down the reactors, just like all the other plants along the coast.
The difference between those two slides was
Yes.
less than a minute.
Right. So there's the plant, and then a minute later, even though they had a seawall, they had a 17-foot seawall, the tsunami was 30, 40 feet.
45.
Okay, so it comes right in, trashes the place. People were describing seeing tanks, fuel tanks, pulled off out to sea and sinking. They lose their backup generators, which should have been fine had it just been an earthquake and not a tsunami. So now they lose their backup generators, and what are they doing? They're running into the car parking lot, is my understanding, grabbing batteries out of the cars just to try to turn on the machines that are telling you what's even happening in the reactors.
That's correct.
Okay, so can you talk me through what happened?
They experienced what's called station blackout. It's every nuclear engineer's nightmare. The paradox of nuclear power is that it exists to create electricity, but it cannot exist safely without electricity. And usually it uses what they call off-site power. What we all use is the power coming in on the power lines to cool the reactor, because what's really important is that you keep the fuel rods cool. You don't let them get too hot because they can melt, and then you'll have, Chernobyl. And so if you lose that off-site power, every reactor has to have diesel generators and fuel supplies for those diesel generators. Fukushima did have the diesel generators, they just happened to be in the basement, which makes a lot of sense if you are in a seismically active area, because you get a lot less shaking underground than you do on the surface. But if you also have a tsunami, you kind of drown your generators.
So what happens next? They're freaking out.
It's
They stay, which I just think is tremendous. These workers stay, scrambling.
They're very dedicated.
They're scrambling to do something. They're like pouring seawater on it.
Well, they weren't initially. They didn't know what
They
had
couldn't
happened.
see inside the
They
reactor.
didn't. Yeah. So they had no information about what was going on, and they did, in a desperate attempt, to go and take car batteries from everybody's cars to try to just get the instrumentation going.
So they could see.
What they didn't realize was that Unit 1. So there are 6 reactors at Fukushima. 3 ended up melting down. A couple of them were offline already, so we didn't have to worry about those. 1 diesel generator did work, and that was able to keep the reactors 5 and 6 going. But 1, 2, 3, and 4, 4 didn't have any fuel in the core, so that was okay, except the fuel was all in the spent fuel pool, which, as Peter talked about before, became a worry after a while. But 1, 2, and 3 were a worry. What they didn't realize was that Unit 1 started to melt. They uncovered the fuel. Water was basically boiled off within a few hours. And they ended up breaching the containment. So reactors have lots of belts and suspenders built in for safety features. So you have the core of the reactor where the fuel rods are, and that's in a very thick steel-walled vessel. Outside of that is a building called the Containment, which is very thick concrete, reinforced steel concrete structure. And then outside that, you have the regular building structure. So that containment provides a lot of protection. The problem is that the design, in part the problem was the design of the reactor at Fukushima. The containments were very small, so it was pretty easy for pressure to build up in those containments, and then the containments started to leak, and hydrogen leaked out because you form hydrogen when water, steam, reacts with the cladding, the zirconium cladding of the spent fuel. And the zirconium cladding strips the oxygen off the water and leaves hydrogen. You get hydrogen gas, which is really explosive. And so within a couple days, in Unit 1, the top of the building blew off. And then that happened again with Unit 2, and then Unit 4, strangely enough. The hydrogen built up in Unit 4, but it actually came in from Unit 3.
So there are these explosions. People are evacuated. The city's now, the town, I guess not really
Towns.
a city, the towns are abandoned now. But there was something much worse that could happen, which you mentioned, Peter.
Yeah, so there was
something much worse almost happened.
I mean, the problem was this: the pools have actually, and in the States, even more spent fuel than was in Fukushima. But you can have in a pool 4, 5, 7, 10 times the load that's in a reactor stored there. And the fear was,
In the way we were describing.
right,
just
and
stored in
the
pool.
fear was that could catch on fire. But and if it had been, then the question is which way the wind is blowing. Fukushima was lucky in one or two ways. Lucky given the disaster. One was that it was on a Friday, I think, rather than a Saturday, Friday afternoon, I believe. And the weekend shift is much, much smaller. So one of the things that was one worry. The other is that the roof was off, so you could get water in through there. The helicopters didn't really work, but the fire trucks did. And a third is that the wind was blowing away from Tokyo. It's about 140 miles from Tokyo. And one of their worries was that if the winds blew over one of the other plants, there's another plant called Fukushima Daini that's triangularly nearer to Tokyo. And if that had to be, and that had melted down, that was another worry that the prime minister had. So the wind was blowing mostly out to sea, and then it blew northwest, and a lot of it got picked up in the hills. So sometimes people say, well, how far away did you have to be safe? That's the wrong question, because there are places where you can be actually fairly close and not in that radioactive areas. And then when I was there with Rob Moss and our team filming, we were pretty far up in the hills, and there'd be roads that were closed. It would change from day to day because the wind would shift, even blowing up the dust. Another thing that people often don't realize is it's not one little town. It's a lot of towns. It's a district. And along the stripes of where the wind blew and the hills rise, you can have very radioactive materials.
160,000 people either were forced to evacuate or chose to evacuate, and some of those people have been able to move back or partially move back. In other words, they're allowed into their houses for part of the day, but not all of the day. But essentially, those people lost their livelihoods. A lot of agricultural land had to be abandoned. It really devastated the fishing community there. So.
You should see the exhibit in the smaller room is performance artist in Fukushima. It's really very poignant.
I mean, sometimes people think, well, why didn't they just stay? Well, during the accident itself, March 11th and the days following, no one knew what was going to happen. The Nuclear Regulatory Commission, before Alison's time, the previous chair and his team actually thought the pool was on fire at one point. And they called for an evacuation out to 50 miles of Americans. There was real uncertainty about where the radioactive material had gone. Had it gotten past the containment walls? How many of them had melted down? There was a lot, so people had to leave. Now, once you leave, I once met a developer just on a flight, and he was talking about the area, out west in Nevada, these big housing complexes that failed in the 2008 economic crisis, and he said he was building new subdivisions. And I said, well, aren't there all these subdivisions that were just abandoned? And he said, if you leave a house for 6 months, a year, you can't go back. There's black mold, there are rodents, you can't. Now imagine that you're not in the desert, basically, as you are in parts of Arizona and Nevada, but you're in Fukushima, which gets plenty of rain, and there's a lot of water around. And when visiting people's houses, they were struggling, even they go back once a week or once every 2 weeks, just with mold and and rodents and insects, and it's really tough to keep a house going, as we know. So, and then you say to people, why don't you move back now? And they say, but there are no doctors, there's no grocery store, there are no schools, and to be none of the kids are going to come back. Pregnant women don't want to be there. Mm-hmm. Families have been split apart. Mm-hmm. Some of the men that work there still, because they have a lifetime job, are separated from their families. The Japanese talk about atomic divorces because their families have gone, really pretty far, hundreds of miles away. And so the situation is, sometimes people act as if it's just people's ignorance and stupidity, and if they knew more about nuclear power, they would come back. But coming back, no one's ever tried to re-inhabit town after town with no support.
Let's look at Chernobyl. Just really quickly, we're not going to talk a lot about Chernobyl. This is the greatest, thank you, I was getting chilly. This was the greatest human-made disaster in history, was it not? That's how it's been quoted, at least. When Chernobyl, it was 20-some years ago, 25-some years ago, in the Ukraine, had its nuclear disaster, which seemed all too easy. It was during a kind of safety test, and it just very quickly spiraled out of control. We won't talk a lot about Chernobyl, but these are photographs of Pripyat, which is where a lot of the workers lived, and it's a completely abandoned town, except by animals. Right? The wildlife has taken over. The forests apparently burn ginger from reactions to the incident, but the animals have taken over. It's like an animal sanctuary now, with these sort of abandoned structures that were left over. And we really only have a few minutes, but I just want to do the next slide and talk about, we've been kind of doom and gloom, which is really easy to do with atomic energy, but it also kind of, if we can do the next one, feeds into naive fears, because the truth is this, if we could run this, is during the Paris climate talks. This is from the Washington Post, showing footage of China during the Paris climate talks just a week ago in this incredible smog outbreak, which was from coal-fired plants. And I think that when we talk about nuclear energy, it's scary, but so is coal. Coal is scary, right? This does not look very good. The air quality was so bad it was technically off the charts, meaning the charts stopped at numbers as emergency levels far below what they were recording here. And I think it's interesting that other form, like you brought this up in the beginning. You said, look, you need to heat the water. It runs the turbines make the electricity, but you could heat it by burning coal. You could heat it by burning gas. These are terrible pollutants. James Hansen says we're dumping waste into the atmosphere at catastrophic levels, and I think it's really hard to deny that this has run out of control. And so, given shale, fracking, coal, tar sands, all this stuff, versus nuclear energy, is there a promise of a better future? A lot of what we're talking about here, these disasters and the problems with waste and things like that, are soluble problems, are they not? Or are they not? Are they soluble problems? With better designed nuclear plants, could we recycle and not dump so much in the ground? Could we have better efficiency?
Recycling, we don't want to go there. It's not recycling like recycling these bottles.
It's
Neither is that.
doing
Let's
what
be
we did to
honest.
Meltdown, basically.
Right, yeah.
Sorry,
it's
Pete?
it's creating a weapons hazard. And,
So a
and
terrorism
a lot
hazard.
more waste.
Sorry,
a lot more waste.
I don't want you to brush over that. One of the concerns with recycling is that you make weapons-grade plutonium.
You separate the plutonium. It
So
could
now-
be diverted into nuclear weapons.
So now you have a terrorist threat,
Yeah.
a real terrorist threat.
Or depending on what country does it, they could decide to develop a lot of nuclear weapons.
So people are very scared about this principle of recycling.
No. Some people are very enthusiastic about it, but I'm not
It's
a big fan.
expensive also, which is probably what's going to do it in.
Yes, exactly. It's not going to happen in the United States because uranium is plentiful and it is much more expensive
But
to
there
do.
is actually a moratorium, a congressional block since Carter
No.
in the 70s on,
No, it's not
I thought,
it's
recycling.
not congressional. It was just an indefinite deferral.
Okay, but it really changed the policy in the States.
Yeah.
Whereas policy has continued, as you said, in other countries.
A few.
So it deterred the policy in the States. But you are not optimistic that we could design a plant that did not produce so much waste, that avoided these greenhouse emissions, that protected us from this carbon dioxide loading into the atmosphere. Or are you? Am I answering your question?
You are, but what I think is that there's no free lunch. There's no energy source out there that is going to satisfy everything that you need to satisfy, be safe enough, not produce waste, etc. You know, not be difficult in putting on the grid, not require lots of storage that we don't have. It doesn't exist. There's no silver bullet. And so it's complicated, and we all have to struggle with it. There's no easy answer. Some people say, yeah, no, I'm against nuclear power because it's, you know, look at Fukushima. I don't want to make that sacrifice. But, you know, look at coal and natural gas. I mean, we are now committed to a very big sacrifice
The
from
Exxon
climate change. I
spill.
mean, just go outside. It's December, folks.
I'd say give it a couple more degrees. Make New York ideal.
No, I don't know. This is wrong. It feels wrong. I grew up in Connecticut, so. But you know, this is difficult. We have to struggle with this. I can't give you an easy way to think about it.
I mean, I think one thing is, it's not, I agree with Alison, it's not going to be one magic source. There are some test reactors, prototype reactors, that are more modern and better than the ones that were sort of carried over from nuclear submarine reactors back in the day, 50, 60 years ago. But getting reactors scaled up, you know, it's like oncologists will tell you, you know, if we were trying to cure cancer in rats, we'd be done a long time ago.
Stop giving it to them.
Scaling it up to the human body has all sorts of complications that are really deep. And scaling up a test reactor to something that you can put on the grid, the problems of plumbing and sealing and, you know, I mean, using salts and keeping it from turning into blocking. So it's probably decades away. So we have to do something a lot before then. I think just gesturing to a magical future is not a good idea. But there's some things to be optimistic about. I mean, since in the last years, solar power has gotten much more efficient and much cheaper. We're at a moment when oil is extremely cheap, but that's not going to last. And when it rises, it's going to make some of these competing forms more economically feasible. I think there's, you know, the wind, there's conservation, which we've only scratched the surface of. Our cars are ridiculously inefficient as a fleet. So we have housing, factories, automobiles to make much more efficient. Solar is going to do better. Wind is going to do better. And, you know, even this, I'm not a fan of fracking or gas, but gas is better than coal. Coal's the worst.
Coal is the worst. I think that was coal fires that you see in China contributing to this.
So, you know, and I think one final thing, which is this impossible but necessary task of trying to think about how to keep people out of these waste sites, has one good feature, which is it's one of the few examples about where we're thinking about our descendants more than 2, 4, 6 years from now. And that's a good thing. And, you know, to the extent that people, not that it's going to work for 10,000 years, but that we're trying to think about the future as we are with global warming is good.
Well, maybe we just shouldn't use electricity. We would solve a lot of problems. Okay, beautiful, wonderful discussion. I want to open it up to questions. We'll just take a few questions if there are any in the audience. I think here on the side, and then I think the mic's going to come around. Okay. We have another one here towards the front too. Thanks.
Recently, I have come across that France has invited tenders for making cars less than 7,000, only solar. I mean, that's a great initiative. As USA, we can be the leaders in that. We can be initiating the things like, I think you might be knowing about that. That France has invited tenders for solar cars that's less than 7,000, all solar cars. So, I mean, initiatives like this that save, the carbon and it solves our energy problems. It's a great initiative, I think.
Okay, so you're saying France is taking an initiative in solar power.
Yes.
France is also using like 80% nuclear power. France
Yes,
loves
but
nuclear
it
power.
has taken initiative. I mean, the initiative, we can take. The solar power we are not discussing, we have left it far behind. We are not discussing it. The one more question is, why have we left the space? I'm a novice, but why we are not still discussing, because you shown one, the rocket going up and it fell down, but why are we not still thinking about sending the nuclear waste to the space?
You guys want to try space?
Because you don't want even one rocket with nuclear waste on it to blow up. It'll spread the nuclear waste through the atmosphere and you'll all breathe it in. You can't afford one mistake. And also it would be pretty darn expensive.
So no space agency, private or government, has a fail-proof record. Every agency, including SpaceX and more recently the galactic spaceship of Branson's Project Virgin Galactic, as well as obviously NASA, as well-intended as all of that is, all of them have had disasters that have not made it out of the atmosphere.
I mean, we have 10,000 tons, I think, of spent fuel in the United States.
We have over 74,000 metric tons.
So that's millions of pounds.
The solar initiative in France, the policy-making initiative, do you think this is just political or economic lethargy on our part? I mean, I've always heard solar was not likely to ever be a base producer of energy 24/7.
The answer is storage. If you can get storage to where you can store the electricity that you make with the completely renewable resources like wind and solar, then you've solved that problem. Then you can move to an entirely renewable.
This is dumb, but why can't you store it in like batteries? Why can't you make batteries?
You can, but
batteries are
not
toxic.
terribly efficient.
Yeah, and they're also really toxic, bad stuff.
They don't last that long. Again, you run into you're going to have a waste problem no matter what you do.
Another question here, please.
I'm not sure if you know, but how much are scientists involved with Congress in terms of nuclear energy? I mean, as we've seen with climate change, the people that are in charge of it don't believe in climate change, so...
There's scientific committees.
The nuclear industry has a lobbying group, the Nuclear Energy Institute. They spend a lot of time talking to Congress. Some of them were former congressional staffers.
So what about less economically motivated scientists? There's the Union of Concerned Scientists, of course, and...
I would say that, that sometimes the papers, well, at least our American newspapers, tend to try to make issues into two equivalent sides, like there's scientists who believe in global warming and scientists who don't believe in global warming. But overwhelmingly, scientists think there's human origin of global warming. It's real, and it's by humans. And if you look at the actual published papers, that's what it tells you. And I think that that's true about the nuclear power among environmentalists. There are some famous people who are pro-nuclear, worried about climate change. But if you talk to the big environmental NGOs and activist groups, they're overwhelmingly worried about nuclear power.
Are you worried about nuclear power?
I'm worried about, for instance, here's something I'm worried about. China is thinking of building over 100 nuclear plants.
That's alarming.
And the Chinese engineering, when they built, for instance, schools, were catastrophically failed in recent earthquakes. And as Ai Weiwei, the artist, has shown in many of his pieces with the backpacks and so on, there were many thousands of children who were killed. With the Three Gorges Dam, a lot of engineers are worried about the way that was built. If you're building all of a sudden and in short order 100 nuclear plants, I worry about it. When you go into a nuclear plant, I mean, Allison referred to this before. I mean, it looks like, I mean, my great-grandfather was an electrical engineer. That's what it looked, you know, his lab, which I saw when I was a kid, looks like a lot of these plants with gas gauges and like chart recorders with like a little pencil on the end of a stick being moved by little servo motors. I mean, it's like there's nothing digital.
The new plants are all digital, but don't want necessarily a digital future because digital is potentially
Not going to last 10,000 years.
hackable.
Right.
Yes, it's subjective. But just a little addition on Peter's discussion on the Chinese nuclear plants. You know, we had over 100 reactors in this country. We now have 99 that are operating. So that the scale of 100 is not really something of great concern to me, but it's whether it actually makes a difference, and it doesn't. So right now, nuclear power in China with, I don't know, 20 or 30 reactors, I never get the number right. There's 21 that are either operating and 30 under construction, or it's the other way around. But anyway, right now, nuclear supplies 2% of China's electricity needs. If they build out to their wildest dreams by 2030, nuclear will supply 10% of their electricity needs. And what do you think the rest is going to be?
Coal?
That's right.
So
One thing, though, that, you know, the economics is important. A lot of the plants that are closing in the United States, and several have on the East Coast, I mean, Vermont Yankee closed, and the Plymouth plant near Boston is closing. And one of the reasons Plymouth is closing, they were already kind of marginal economically with cheaper other forms of power, but they were told that they had to conform to post-Fukushima safety standards, and they said, you know, if we have to do that, we'd just rather close the plant. And they may have closed it anyway, even without that, but so plants are closing, and they're not closing because of protesters, and they're not closing because they suddenly went green. They're mostly closing because they're losing money. And Plymouth was losing, I don't know, $40, $50 million a year.
Well, in part, that's because we deregulated the electricity market, but that's another story.
I want to get another question, but just very quickly. Of these just under 100 plants, in your position, having inspected, you know, overseeing the extension of the licenses, how many of them do you think are not safe? Or
I think they're safe. What you don't realize probably is that at every nuclear power plant, there are at least 2 inspectors from the Nuclear Regulatory Agency who are there all the time. Their job is to inspect these plants. And they, you know, have a whole series of things that they look at all the time. If any incident happens at all, they are immediately in the control room.
But no plant has ever been denied an extension of a license, is my understanding.
That's correct, but what happens is plants will start to apply, and if there's a problem, the NRC will tell them, look, you've got a problem here.
Discourage them.
And you go back and you fix it, or you don't apply. Yes. So it looks like that everything, you know, they let everything through. But in fact, there's a lot that goes on in the back room that you don't know about. So, and by the way, just, you know, the inspectors are really impressive folks. So they should make you feel safer. They're really good, solid people, and they are not allowed to fraternize with the licensees at all. They're not allowed to socialize with them. They can't go to parties with them. They can't eat lunch with them. It's a bit of a strange situation for them, and some of these people are really in the middle of nowhere, but that's the deal. And they only can stay at a particular facility for up to 7 years, and then they have to move on.
I've got another 20 cards here, but whoever has the mic, it was, can you pass the mic? Okay, there's a mic back there, yes.
Okay, so for those of us who are neither geologists nor particle physicists, can you tell us how safe it is for a country like Japan with like 54 nuclear power plants, small island nation, seismically active, to bury its nuclear waste?
It's not really that much nuclear waste, really, and it's a hell of a lot better than keeping it on the surface of the Earth. So
Are they burying it, or are they leaving it
no,
as we
Japan
are?
is trying to decide what to do. They're hand-wringing right now.
I think there's a sort of
So,
50-year
no, I mean, what are the
leeway.
options? Because, I mean, I realize that for us, it doesn't seem like a lot because you're talking about weapons-grade kind of waste, and we're, but for people over there who, as Professor Galison could expand on, I'm sure, their lives are ruined from just this, one plank going to hell in a handbag, let alone 54. So they're a little antsy about it, and right now they're seeing all this sort of cesium-packed soil kind of sitting on, taking up a third of their farmland, which they can't farm on anyway in those regions. So for us, it might not seem like a lot, but is it safe for them to
Sure.
bury
the
whatever
waste.
they have in
Yeah.
that seismically
and
active country?
they're beginning to realize they have to start making progress on developing repository sites in the country. So I think they can do it safely. As long as it's well regulated, they'll do it safely.
Will countries internationally take waste and exchange it?
Well,
Or
there's-
is this going to be each country's individual problem? Or are they going to accept, oh, my country has tsunamis and is seismically, it's small and seismically active, let's make a trade, you take my waste and I don't know.
I mean, one of the problems is there was a lot of abuse some time ago with international movement of nuclear waste. The mafia took control, for instance, of a lot of nuclear waste in Europe and dumped it off the coast of Italy.
What nuclear waste are you talking about?
And
It's not high-level nuclear waste.
No.
I don't know what
But-
it is, but anyway, I've not heard that before.
So, you heard it here. And there was worries that a lot of it was going to get shipped to Africa, and there were regulations put in place in Europe that makes it very hard to export nuclear waste. Now, a consequence of that is the Netherlands, for instance, which, as the name suggests, is the low country, and having nuclear waste below sea level is not probably the best idea in the world.
But you just agreed with me earlier that it's good to put the nuclear waste below the water table. And Sweden has, they're in the process of licensing a deep geologic repository for high-level waste. They already have a geologic repository for low and some intermediate level waste, and that is actually out under the sea. And it's fine.
I mean, basically, I think we have to bear in mind when we're talking about all of this, as scary as the nukes sound, all of these other forms of energy are also very scary.
And even within the
and
nuclear
damaging.
sphere, it's like if you have it in pools, where almost all the waste is, the high-level waste is probably the worst thing you could do.
Right, right,
So,
exactly.
so I think that it's...
And that's where a lot of it remains. The commercial waste remains.
It's like the jazz song, compared to what? And so if you say, is it safe, could it happen that the underground repository will leak? We know they can leak. They have, as in the WIPP site.
Yeah.
But is it better to keep it on the surface in these pools? No, it's worse. Or you could say, well, get it out of the pools and put it in these dry casks, these big thermos bottles of concrete and steel. That's better than being in the pools.
That's only 50
But
years,
it's
100
50
years.
So that's not a long-term solution. And then who's going to take care of that in the future becomes a problem. So I think that the way I would answer the question about what's safe is compared to what. And if you have the option of producing more nuclear waste, I think you have to take into account what's going to happen to it down the road. If you already have the waste, then you're always comparing, and in Japan they have special problems, like the population is concentrated along the coast, you have mountains, you have a lot of underground water flow, which is what's happening now in Fukushima, that passes under the plant, and it causes local contamination of the water and the fish near the coast. And that's why the fishermen are sitting in their boats every day doing nothing.
So we have, I think I'm sorry, a last question, because we're running a little bit over, and then we can all grab a drink, and people can ask questions as we try to run out of the building.
I have only one question. Has anyone on the panel heard of Thomas Bearden's 9.1 minute isotope forcible?
It has a half-life of 9.1 minutes?
It has a process that causes a 9.1 minute half-life using scalar waves. Anyone
No.
aware of that?
I've never heard
It's
of
not
that.
the only one to come up with something similar to this, but it's a 9.1 minute, it's a patent application. It hasn't been assigned to him, but it's in a process. He's distributing this as an open open discussion.
Here's the obvious argument to that, which is, look, now we truly have safe nuclear power because there's no waste problem because it only lasts, its half-life is 9.1 minutes, and times 10, that's a completely reasonable amount of time to wait for something to dissipate. But, you know, I don't know if these things are actually atomically possible, but we can't foresee these things. I mean, 1905, the greatest genius of the time did not foresee chain reactions of nuclear fission, and so who knows what's possible. Do you have responses to these? So on the note which says we can stump some of the cleverest people in the world, I want to thank our guests and thank everyone for coming, and please stay for a drink and some music.